Hi everybody, very good morning. This is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SS College of Technology, Coimbatore. So today, in our lecture series, we have been discussing about the different smart grid technologies. In the last few videos of our lecture series, we have been seeing number 3, where we are seeing the concept of microgrids and the DT-based case studies on microgrids. The last video, we have been discussing about the various classifications of microgrid, what are the types of microgrids, how does a microgrid operate, what is a microgrid. And now today, this video, we are going to discuss about the microgrids and its operation and how the control structure of the microgrids. How does the microgrid control system works? So that is going to be today's topic. So come, let's get into the video so you see about the control system in a microgrid. Integration of voltage class. Microgrids can integrate into grid at the following 3 different voltages. One is 380 volt, second one is 10 kV, a hybrid system of 380 volt and 10 kV. So all these could be possible with the structure. So the principal roles of the microgrid control structures are voltage and frequency regulation for both operating modes, proper load sharing and DER coordination, microgrid resynchronization with the main grid, power flow control between the microgrid and the main grid, optimizing the microgrid operating cost. So hierarchical control levels of the microgrid consist of 3 different levels. The 3 different levels of controls are available in the microgrid. So what are the 3 different levels of control? One is called as the primary control, second one is called as secondary control, third one is called as the tertiary control. So what are the three levels we will see in detail? One is primary control. So the communication channels is connected to a microgrid control center through the secondary control and the tertiary control. It is also connected to a primary control center where it have the different battery packs, power electronic converters, and the local loads. This is the common block diagram of a communication channel and the control levels of a microgrid. Primary control. The primary control provides the reference point for the voltage and the current control loops of DERs. These intercontrol loops are commonly referred to as the zero-level control. The zero-level control is generally implemented in either PQ or voltage control modes. The primary control is designed to satisfy the following requirements. To stabilize the voltage and frequency, subsequent to an islanding event, the microgrid may lose its voltage and frequency stability due to the mismatch between the power generator and the consumed. To offer plug-and-play capability for DERs and properly share the active and reactive power among them, preferably without any communication links to mitigate circulating currents that can cause overcurrent phenomena in power electronic devices and damage the DC link capacitor. So this is the role of a primary control. So the primary control is designed to satisfy all these requirements to stabilize, to offer plug and play, and to mitigate the circulating current. So this is the work of a primary control system. Now, next we are going to see about what is a secondary control. So what happens in each stage of control system? So the bandwidth reduces. During the primary control, it is the major control system. Power sharing happens. The local dynamic sharing happens. Voltage control and current control is maintained by the primary control. When it goes to secondary control, it just narrows down. What is taking place in the secondary control? It just sees about the grid synchronization and the power quality. And finally, tertiary control, it reduces its bandwidth. That is power flow control and energy management is alone taken place, monitored by the tertiary control system. So this shows you the triangle where the primary, secondary, and tertiary control deals with. What is the secondary control? So a primary control may cause frequency deviation even in steady state. Although the storage devices can compensate for this deviation, they are unable to provide the power flow for load frequency control in long terms due to their short energy capacity. The secondary control as a centralized controller restores the microgrid voltage and frequency and compensate for deviations caused by the primary control. This control hierarchy is designed to have slower dynamic response that of the primary, which justifies the decoupled dynamics of the primary and the secondary control loops and facilitate their individual design. So this you can see the primary control, secondary control, and tertiary control. What are all the different control techniques taken up by the each stage of its operations? Tertiary control. Tertiary control is the last and the slowest control level that considers the economical concerns in the optimal operation of the microgrid and manages the power flow between the microgrid and the main grid. In the grid-tied mode, the power flow between the microgrid and the main grid can be managed by adjusting the amplitude and the frequency of VERs of voltage. So upper levels of operation, you can see the three different levels of physical level of microgrid system. That is the primary level, secondary level, and the tertiary level of microgrid operation. So these are all called as the different levels of control system in a microgrid. So control bandwidth analysis of hierarchical control levels. So primary, secondary, and tertiary. So time scale analysis, when does the primary distribution work, secondary distribution work, and when does the tertiary distribution is going to operate. So with this, we are going to come to the end of the video. That is, what are the various levels of hierarchical control levels of microgrid system. Thank you. In the next class, we'll just see about the next topic on microgrid. With this, I'm just leaving to you. We'll meet in the next video. Thank you.